and Kubernetes. And Docker and Kubernetes are actually two different technologies, two different companies, but they're frequently used together. So Docker's a company that's driving the container movement across the enterprise. And this Docker was officially launched in March of 2013. So pretty new technology, not even 5 years old yet. And surprisingly well adopted across many, many companies. I have lots of developer friends that are using it. Have talked to lots of companies that have already a Docker infrastructure in place, and really popular. For only being around 5 years, it's probably the most popular, fastest growing deployment platform, or even just general technology that I've seen. It's rare to see something grow this fast in such a short amount of time. So Kubernetes is an open source platform developed primarily by Google for managing containerized workloads and services. So Kubernetes is kind of, you might hear it as the glue or the traffic cop software that lets these different microservices in these containers work together and talk together. So Kubernetes is all newer, released July of 2015, so not even 3 years old yet. But Kubernetes solved a big problem with the enterprise deployments of Docker. How do we get these Docker microservices to work together? So that's Kubernetes' job. So a really basic question, well, what are containers? So containers, lightweight standalone executable package of a piece of software that includes everything needed to run it: the code, the runtime, the system tools, system libraries, settings, everything. And containers isolate software from the surroundings. So for example, differences between development and stage environments, and they help reduce conflicts between teams running different software on the same infrastructure. So containers actually allow you to run software applications on the same hardware that possibly you couldn't do before. So if you had two different, say a Linux environment, you had two different applications, they both needed different versions of Java, they both needed to use the Java home directory, there would be no way to run those two applications on the same server. You basically have to run them on two different servers because of the conflicts in the software. Well, containers isolate all of that information and allow you to run those applications concurrently on the same hardware. They don't, the software doesn't know that the other software is on there. Everything about the software is contained in these Docker containers. So it's really useful for sharing infrastructure, and that's really the biggest advantage of containers, is the ability to share more infrastructure. You can run multiple applications on the same hardware without having to worry about any software conflicts. You're more concerned about how much memory am I using and how much CPU do I need. There's just a little image. This is right off of Docker's website. If you go to Docker's website, how the containers work. And this is, say, 3 different containers. One's got Tomcat, Java, and Debian in it. The other one's PHP, MySQL, and Ubuntu, running on Ubuntu. And the other is just static binary with Alpine. And they're all running on top of one kernel, one single, in this case, would be Linux kernel. So some of the benefits of containers, they're very lightweight. They share the underlying OS kernel and use less CPU and RAM than apps installed on individual machines. So for example, if you've got, say, Service Manager, you install that on a Windows or Linux box, every instance, every app server instance of Service Manager that you install has to share resources with the underlying operating system. And whereas in Docker, you could actually run 5 versions of Service Manager on the same machine, and they would all share the underlying RAM, CPU, everything on the machine, but they'd all be separate from each other. So instead of setting up 5 different servers, you could run them all on one server. And they use a lot less resources because they're not running an entire operating system underneath them. They're just using the existing operating system, and they're all sharing the operating system. So very much like if you've ever built a virtual machine and you've got it like a differencing disk where the core OS is sitting on one disk and just changes are going to the other. It's very similar to that, where just the differences are stored in the container. Everything else uses the base OS. It's everything's standard. Everything's based on open standards. They run on Linux, Microsoft, and cloud environments. So one of the great things about containers is if you develop an application or purchase an application that's deployable in Docker, you can run it anywhere. You can deploy anywhere that Docker is loaded. You can deploy it locally in your environment on Docker. You can deploy it. All the cloud environments have Docker instances you can run it on. And even share between Linux and Microsoft, although that's still pretty early, and I will talk about that. But in our dev environment, we run Hyper-V, and we're actually running Linux on top of Hyper-V. So we're running all of our Docker on Linux on Hyper-V. So we're more of a Microsoft shop, but we're able to run the Linux Docker apps on top of our Microsoft Hyper-V platform. And Docker apps are very secure, so they're isolated from the operating system. Operating system does not have access to these Docker applications. So any hacking into the application from the underlying operating system, and the other way too, the containers don't know anything about the OS. So if there was something in your container that was destructive, it doesn't know anything about the operating system and has no way to get to the operating system. It has no way to run against the file system or anything like that on the operating system. So in a case where you had a virus or some sort of application that gets loaded onto a server and had access to all the server resources with Docker, and you just can't get into these containers. They're totally separate from the operating system. They can use objects on the operating system, but it's actually passed through the Docker layer to the application layer. So they're very secure. How are containers different than virtual machines? So typically, like even in our lab, we run a lot of virtual machines. At all of our clients, they get their own virtual machine, and it's kind of wasteful because if I bring up a new environment for a customer, I've got to create a machine just for them and load their software, typically vendor software on there. And we're sharing possibly database space, but every single client, I've got to load another machine and stick their software on it. So the software's got to be installed on each server in a virtual machine. All the prerequisites have to be loaded on each server. Conflicting, this is just virtual machines. Conflicting software can't run on the same machine. So like even in the Micro Focus ITOM suite, you really can't run, say, the chat service and the web tier on the same machine because they conflict. You can run web tier and service manager on the same machine. There's no conflicts, but the chat service and the web tier, there's some issues if you run them on the same machine. With Docker, it doesn't matter. Every additional software install requires a new OS, wastes CPU and memory. So every time you got to install software, if you're deploying a new OS, Windows 2016 server, I mean that takes 4 gig just to run. We have 4 gig allocated for a 2016 server with nothing on it. We end up using probably between 8 and 12 to run something like Service Manager on 2016. If it's not, if 1 or 2 people are using it. So and 4 of that is just for the operating system. Instant on. So instead of booting an operating system, you're starting a container. Probably not a big deal in internal systems, but if you're out in the cloud and you're paying especially on development systems, a lot of times you're paying per hour, per minute. So you're firing these things up. Instead of firing up a machine and having to wait for it to boot, you're just basically turning on a container and the application is starting, and they start really fast in these containers. So Docker, how is it different than virtual machines? So only the Docker software must be installed on each machine. So we've got an application we developed internally. The web server went down. I hadn't installed it in years, probably 5-6 years on our internal server, and I had to figure out it was kind of an older web technology it was built on, and I had to figure out. It took me a day to figure out how to configure IIS to get this web application to work. And if if Docker had been around when I first deployed it, I just would have compiled it as a microservice and deployed it in Docker, and then all I would have had to do was put Docker on my machine and deploy it. I wouldn't have wasted an entire day trying to configure IIS to run this web app. So with Docker, you only have to have the Docker software installed on the machine. The prerequisites, everything the software needs to run are loaded in their container, and they call all the services microservices. You'll see that term used a lot. Even multiple instances of the same software can run on the same machine. So you can run 10 versions of Service Manager on the same machine if you wanted. There's no conflicts, and you kind of can anyway on Windows, but it's just really easy with Docker. Like I said, the software prerequisites are packaged in the containers and don't need to be loaded on the underlying machine. So that's a pretty big one when you're talking about deploying software. You don't have to worry about, what version of Java is loaded, what version of IIS do I need any of these ISAPI plugins, or all of that are contained in these Docker containers. So you just deploy the container or containers, and everything is there that you need. So it's a big advantage. So why do developers love containers? So I've got a lot of friends who are developers, maybe not in the ITSM world, but just out there developing, and this technology is really catching on. So why, ask them why do you love these containers? Well, the biggest thing is deployment. Super easy to deploy. So I can write a .NET app and deploy it to any Windows server running Docker, basically any Windows 2016 server. I can deploy it to Azure. I can deploy it to Amazon AWS, Rackspace. All of these cloud technologies have Docker support, so it's super easy to deploy. Same thing on Linux. If I've got some type of Linux app, I can just deploy it without having to worry about, is this library loaded? Is that library loaded? Are all these prerequisites? You don't run an install. You just deploy your containers over the infrastructure. So there's very little setup. As long as the environment I'm deploying it to is running Docker, my app will run. No more installing all the prerequisites, software needed by each machine. I just deploy the Docker container. So just kind of a visual way to think about this. The old way on the left, applications on the host. So you can see multiple applications, and this is on Windows or Linux. You've got multiple applications running on the host. They're sharing libraries which are communicating with the kernel, the underlying Windows or Linux. So the library sit on top of the kernel, and then the apps share those libraries. And where you run into problems is that when the libraries change versions for the applications, it happens a lot. If you're trying to run multiple applications on the same server and they're being upgraded at different times, different things like that, the underlying libraries are changing, and pretty soon the apps aren't compatible anymore. And it's a big problem in Windows because there's very little DLL control over or namings, and the same thing with Linux. As versions increase, a lot of times jar files they just add a number to the jar file. Well, the way Java works is it just picks the lowest number and uses that one, picks the first one. So all of a sudden now you've got maybe 2 jar files, different versions, but your application's picking the wrong one. So on the right, that shows how containers are deployed. So the app and the libraries are packaged together on the Docker containers. So the libraries are actually contained with the applications. And the only thing it's really using from the underlying kernel are operating system calls. So very low level networking type things, nothing application, no services, nothing that would run on top of the operating system. So in the Windows world, it would be services, things like that, or maybe DLL sitting on top of the operating system. None of those are used straight from the OS. So only very base core operating system, like file system calls, networking, very low level networking, TCP/IP protocol type stuff is used by the kernel. So you can actually have different versions of the libraries running on the same machine because they are packaged in the containers. I'm just going to see if there's any questions. If anybody has a question, type your question out and I will try to answer it. If it's relevant, I might try to answer it right away. If not, we'll do it at the end. So how does Docker work by platform? So Docker, Linux Docker originally came out for Linux, so it's got a big head start on Linux, on the Linux platform. It runs on top of the core operating system. Once you install Docker, core Linux OS objects are used by all the containers running on that system. And Windows works a little differently. Once Docker's installed, you also have to download what they call a core Windows image for the containers to use. So Docker does not use the host OS resources in that case. It uses an image, and there's lots of different, kind of like Linux, now Windows has lots of different versions of base images. Linux has got like a microservice OS all the way up to your full GUI OS. Windows has got the same thing. They've got like a microservice OS, which is very bare bones Windows, really small, less than a gig, all the way up to like full blown Windows OS, but it's just the image. So that image that you compile your Docker apps against doesn't change. So you can update, patch your underlying, in the Windows infrastructure, you can patch your underlying Windows servers, and anything that's patched on the underlying Windows server does not affect your containers, because the containers are looking at the static image that it really doesn't even need to be patched because it doesn't run. It's just a reference point for the applications inside these Docker containers, and the applications in there, they're so secure. You just don't have the issues with the security holes on these in Docker like you do on a actual running copy of Windows. So you can patch your underlying Windows infrastructure, and it won't affect your image that's sitting on there. And so I think the Windows way is nice. Linux works a little bit differently with patching and things. I haven't talked to anybody that's run into conflicts, but you could have a potential conflict, I suppose, with if you compiled something into your Docker container that's running on the underlying host that changes because of some security patch or something that could affect. So, oops. So do Linux images work on Windows and vice versa? The short answer is no right now. So we're really, really close. I mean, both Docker's working closely with Microsoft and these Linux vendors to get this stuff to work. I would say probably in the next year or two, you'll probably be able to run all your Linux images on Windows without running right now, if you want to run Linux on Windows, you've got to run like on Hyper-V, you've got to run a small OS version of Linux and then run Docker on that. So right now, we're still really early. Docker's only not even 5 years old. And so they're working on it. It's very, very close. In fact, we'll probably see Linux containers being able to run natively on Windows this year, would be my guess from everything I've read. Linux Docker images can run on full Linux VMs running in Hyper-V, which is how our shop does it, how Stratacom does it. So we run Linux on top of Hyper-V. It's pretty efficient. I don't really have a problem with it. It's not as nice as just being able to deploy apps over like a Windows Docker infrastructure, but it's fairly simple to set up. So Microsoft has provided early support for Linux image capability, so that it is out there, and I did check into it to see if the ITOM would work on it, but right now I have a point in here, many features don't work. One of the main features that doesn't work is NFS shares. So when you get into deploying Docker, this Docker stuff for ITOM, you'll find that a very important piece of deploying it is NFS shares. And in fact, the February release has got, I think, 10 or 12 NFS shares. So that currently doesn't work. So that puts a big problem into it. So, and ITOM, I'm not going to dive deep into it, but ITOM on Docker is a little bit different than your standard Docker deployment, where because of this container deployment foundation they've got, which is basically Micro Focus's way of letting you easily deploy a Docker container without an existing Docker infrastructure, and also they give you a way to manage it. So they've really kind of written their own Docker management in case you don't have your own. So. And Windows containers right now don't work on Linux. You have to install a Windows VM. So that's probably coming if you've got Windows apps that you want to run on Linux. It's probably going to work the same way it does on Windows. You'll download a Windows image, and you'll be able to run your apps against that, and they'll run in Docker, because the Docker piece that runs the images, that can really run in any operating system. It's more compiled for a CPU, right? So that can run really on anything. It's really just a matter of this stuff is pretty new and the cross compatibility isn't quite there yet. So what is Kubernetes? We'll talk a little bit about Kubernetes, a container-centric management environment. It orchestrates the computing, networking, and storage infrastructure on behalf of user workloads. Not a traditional all-inclusive PaaS, platform as a service system. And it just provides some generally applicable features common to PaaS, such as deployment, scaling, load balancing, logging, monitoring. So that's what Kubernetes, when you see Kubernetes referenced during your ITOM deployments, and you'll see it a lot, like a lot of the stuff that you do, like even when you start and if you have to stop and restart your CDF infrastructure, you're doing that with Kube, with the Kubernetes. You'll see the KS$8, which is your environment variable for your home Kubernetes environment. So a lot of it's built around Kubernetes. So just keep in mind, Kubernetes is not how the application is deployed. It's rather the glue that holds the application together. So when it comes down to it, as an end user of these kind of off-the-shelf products, you don't need to know a lot about Kubernetes and how it's working, because you can't really change anything, right? It's a kind of developer tool, and we don't really have access to it. It just handles very low-level things like, hey, Service Manager needs to write a log, UCMD needs to write a log. So it handles the transaction between the application and the file share. So that log can be written to a file share so that it's saved. So if you destroy the container and reload it, the logs aren't gone, because Kubernetes handles that. So now we've learned a little bit about Docker containers and Kubernetes. Let's talk a little bit about how is Micro Focus utilizing Docker and Kubernetes. So the core applications are being containerized. So each container contains a microservice. So the Service Manager RTE, the chat UI, the chat service, you'll see like the service portal UI, the service portal service, the idle engine service. You'll see lots of these when you download them. So Kubernetes is used to link all the microservices together and handle kind of some of the low-level things. You might be wondering, how does load balancing work? How do ports work? For UCMDB and for Service Manager, how does all that work? Well, Kubernetes is exposing the load balancing port. It's exposing integration ports. It exposes all these ports. It tells Service Manager where the INI information is. It tells it where to write out the log files. So that's what Kubernetes does. So deployment of the suite includes all the microservices integrated and working. So that's kind of the great thing about deploying with Docker and Kubernetes. If you just deployed with Docker, you still have to do all the integration between the pieces. You'd have to say, oh, okay, Service Manager, here is the port we need to go to for Service Portal, or I guess you'd tell Service Portal the port for Service Manager. Same thing with UCMDB. Because they're deploying with all the Kubernetes kind of automation built in, all of that stuff works. So you can literally deploy the entire suite all at one time, and everything works. Works out of the box. So you don't have to spend time configuring certificates. That's all done for you. And I've been working with this for over a year, deploying probably pretty much every version. And I can say the last version is definitely the best, the February version. You don't have to do things on the server like you used to. Like if you wanted to change the certificates, that was all manual. Now that's all built into the Deployment Foundation web tier. And you can upgrade your certificates right from there. You can do lots of things from the web tier. So a lot of that it's really a lot easier way to deploy, and that's one of the big advantages of Docker Kubernetes is the deployment. So there's lots of others for upgrades and failover and things like that. But one of the biggest advantages, especially with the ITOM suite and all the disparate applications, the deployment, linking them all together, just deploying it and have everything work. It can save you days or weeks of configuration time. It's really nice. So what is the process to install this ITOM suite? I've probably done this 50 times at least. So deploy the requisite number of Linux servers. Right now, only runs on Linux. So if you're a Windows shop, you're going to need to deploy this stuff on Linux. you're on SQL Server, you're going to have to wait. It only runs on Oracle. So deploy the requisite number of Linux servers, minimum 2. That's kind of 2 is for a like a demo system basically. Micro Focus has got pretty good sizing guidelines. One nice thing about using Docker is you end up using a lot less servers than you did if you deployed everything with all the failover needed for UCMDB, Service Manager, Chat, Service Portal. If you had everything failed over, you're looking at a lot less servers. Probably not half, but 60% of the servers, maybe less, maybe half. It kind of depends on how big you are and how big your failovers, how many boxes you have for failover and things like that. So we deployed a number of Linux servers. You got to have at least 2. Got to have your primary server and then a worker server. You download and install the Container Deployment Foundation. So this is the CDF. So the purpose of the CDF is to, and maybe I'll expand on what the CDF is a little more in later slideshows. But the purpose of the CDF it basically deploy the system. So it gives you a way to actually deploy the Docker containers with Kubernetes without having a Docker infrastructure in place. And it also gives you a way to manage it. So get a little management so you can see all the microservices running. So that's kind of their underlying piece that's needed. So could you deploy these Docker containers without CDF? Possibly. I think the CDF does a lot of work though, like generating the certificates. It does a lot of the work that you would have to do manually if you just went and deployed on your existing Docker infrastructure. So it does a lot of that, populates the database if it's a demo system or a new system, with all, in Service Manager's case, with all the RAD applications and all that stuff. So there's some things the CDF does. So Micro Focus's implementation of Docker does have some prerequisites. The CDF is one of them. Some of the other prerequisites it needs are like you need to have zip on the server, so you can. They're all in the primary server because you need to be able to unzip the CDF on the Linux box. So there's some really minor prerequisites on your primary server, and then CDF is installed on that. And then you deploy the CDF to the worker servers via the web interface. So, and that's been a little bit in previous versions. I could rarely get it to work. Maybe 25% of the time it would actually work. I'd have to go to the worker servers and manually deploy it. You just install that SH and run. Now I just deployed yesterday or the day before, and it worked. It to the worker server. It deployed the CDF. No problem, and it took minutes to deploy it. It was really fast. In fact, I thought it didn't work, it went so fast. Then you download the Docker images from the repository. So Docker images are stored up in Docker. That's just how the thing works. You need a Docker account, and then what happens is your Docker account gets linked to the Micro Focus account. They get access to the Micro Focus Docker images, which allows you to download them. It's just a shell script that you run on the server to download these images. And then you actually upload them up into the CDF. That probably takes the longest, honestly, downloading the images and uploading them to the CDF. So I always keep a copy of the images off the Linux box, so I don't have to download them if I create a new environment. But uploading to the CDF, that takes a couple hours, and I don't know if it's because my disks are growing and it's waiting for the disk to grow, or if it's just that slow, but it takes a couple hours. It's 101 microservices to upload to the CDF, so it does take a while. And then you just deploy the Docker images via the CDF web interface, and that's pretty fast. I mean, you have to match up your network file shares. So you say, hey, your core ITSM data like logs and INIs sits on this file share. So there's about 10 of those. They're just in a drop down. You just pick them, and then you just click a button and wait, and it deploys. It might take an hour. It kind of depends on how much CPU you have and how fast your network is. So it's pretty simple to deploy. Now, I will say from experience that all the deployments that I've done over all the different versions have had their little inconsistencies in the deployment. So things like the Oracle jar not getting copied over for this the Oracle connector. So you have to put it in a specific place. And, Micro Focus has been fixing all those as the things are rolled out. So just an example, the last thing, if you're on the message board, you might see, but if someone else had the same problem, we couldn't deploy, we got an error deploying, and it turned out like, because I don't have a full-fledged Linux infrastructure, I don't have DNS for my Linux, I need to update the Etsy host file with the Linux server names and IP addresses, so that because the certificates use the fully qualified domain name, but they weren't resolving to an IP address. Since I don't have, I put them in my DNS for my Windows servers, but my Linux servers don't use my Windows DNS, so I need to, and so that's kind of because I'm a Windows shop and running Linux on top of it without a fully baked infrastructure. That's something I ran into and somebody else ran into also. So what are some of the advantages over traditional deployments? Well, the suite components are deployed already connected to each other. So especially for if you're just getting going or you're installing new versions, boy, this is a big advantage because, you got to install Service Manager. Maybe I'm installing it on 5 machines. Maybe I've got USMDB on 2 or 3 machines. I've got the web tier. Maybe I've got that on 3 machines. I've got to deploy that WAR file on 3 machines. And then if you've got chat, well, that's another machine. So all these installs on all these machines, and here it's just one install, one deployment, and it all happens at the same time. And then in a traditional deployment, you've got to install them separately and then connect them all. You've got to do all the certificates if you want HTTPS. You've got to do all the set up all the ports and do all that. And that's when you deploy all at once, all of that is set up. So like I said, it's set up out of the box. So it might not be set up the way you want, especially your USMDB to Service Manager integration. That's just going to be out of box. You probably are going to want to change that, but at least it's set up and working. Resources are spread evenly between computing resources. So normally lightly used applications, i.e. chat, you might have a server set up just for chat. And that thing doesn't take hardly any CPU or any memory, but you got to set up a server for it. So now it just slid into these 2 servers. So imagine now you're deploying USMDB, chat, Service Portal, Service Manager, IDM, which is kind of their identity management piece, like for login. All these different things, you're deploying them all on 2 servers. Like I always deploy in 2. You don't really need more than that for a demo environment. For production, you're going to need more, but I can install all these on 2 servers. So yeah, these 2 servers take quite a bit of memory, but it's nothing compared to what I would have to if I was running 6 or 7 servers and needed to deploy all this stuff. So some more advantages, containers can be moved from machine to machine. So containers don't contain any state information. So everything that's important to a container is contained either in a database or on a file share. So you can just destroy a container and rebuild it on another machine. And of course, they come up almost instantly. It's really fast. And of course, you're stuck kind of with the same issue with these applications as like a hot cold failover, where if you're connected to the application and it goes away, you're going to get disconnected. But you just reconnect and you're connected back to the application. So if a machine goes down or a machine runs out of memory, you may need to move some of these containers. You can just recreate them on another machine. So Micro Focus, I just don't know how much automation there is in moving these containers around automatically. That's supposedly kind of the job of Kubernetes with Docker, but I haven't seen it in practice. I haven't seen it in a really big customer on production and how it's handled, how the resources are sliced around. But you can, like if one machine CPU is being hammered by something and it's affecting Service Manager, you can just move it off to a different machine. New resources can be added really easily. So if you're maxed out on memory or CPU on your existing infrastructure, just throw in another server. You just go to the web tier, the CDF web tier, add it, click the add button to add a new worker node, and now you've got a new worker node. And the one thing I'm not 100% sure is how the containers are deployed automatically. I know how to do it manually, but I'm not sure how to be deployed automatically. So I just don't have a lot of experience playing with that, with the automation. So that's a really nice advantage. So more Micro Focus specific information. Most of the ITOM suite is containerized, but there are some exceptions. So not everything is containerized right now. You seem to be Windows Agent or the probe server, not containerized. It runs on Windows, and they don't have a containerized Windows infrastructure running yet for this. So it from what I've heard, it is on the roadmap, so that's coming. So, and that's been an issue connecting the probe server to the containerized version of UCMDB, especially in older versions. Kind of half-baked. The documentation isn't great. We've had some issues integrating those together. So I haven't gotten far enough along in the February release to see if that's easier or better. But that's one thing that's not containerized. Do I mention? No. Okay, so the other thing, Asset Manager. Asset Manager is kind of a weird egg, right? Because it's basically a database with a Windows app front end and then kind of a web tier. So there's not much on the server side. There is a server piece. That is also not containerized. I've also heard that is on the roadmap. So right now, there's no Asset Manager in these containers. So if you're an Asset Manager shop with UCMDB and Service Manager, you're going to have to integrate Asset Manager with it. Basically, you're integrating the same way to a containerized environment. I mean, you're almost always integrating to a port, right? So the ports are exposed in a containerized environment. So like Asset Manager really can't tell the difference. But that supposedly is coming too. So you can mix traditional deployments with containerized deployments. So a good example is Service Portal. Service Portal only available now on Docker, right? There's no new Service Portal install. So you're going to have to deploy, if you want Service Portal, you're going to have to deploy it on CDF and their container deployment foundation on Linux, running with Docker. But you can set that up with standard Service Manager. You can set it up deployed with Service Manager in a container. It doesn't matter. So you can mix and match your deployments with containerized and non-containerized. So it's one good way to maybe slide into containers. Start with Portal, maybe slide Service Manager in there. Do I mention this? One thing I want to talk about too is that the binaries are the same. So say for Service Manager or UCMDB, the binaries are the same whether you're running on Windows, Classic, Linux Classic, or Container. So if you've got, say, Service Manager sitting in an Oracle database, you can switch between containers, Windows, and Linux. Any of those three combinations, you can connect to your Oracle server with the same binary version. So those binaries are the same. So if you're running, say, Service Manager 960, brand new 960 on Windows, and you want to go containerized, you would just deploy your containers, shut your Windows servers down, and connect your containers to your Oracle database, and you'd be up and running. You don't really need to do anything else. Because the binaries are the same, and they just connect. All the important stuff's in the database. So your INI and stuff you'd have to copy over, but there's not much that you would have to do to move to containerized. It's not like a big upgrade, unless you're on an older version. You got to keep that in mind. You got to be containerized is 9.5, 9.5.2, and 9.6, and the newest stuff in 9.6 only. So SQL Server, if you're on SQL Server, not supported. You change that. So right now, only connecting to Oracle, and part of that is kind of the classic issue of I'm on Linux, I want to run SQL Server. What are my options? Well, they're not fantastic. They're not great. I haven't run into any companies that are running against SQL Server on Linux. It's technically possible, but I don't think it's supported by Micro Focus. So right now, if you're on SQL Server, not supported. Will Micro Focus come out with a Windows containerized version of SQL or of Service Manager UCMDB? Don't know. I just don't know. It would be nice. I haven't heard if that's on their roadmap or not. It'd be fairly easy to do, but I'm not sure if they're going that route or not. So right now you got to be on Oracle. So is it a pain to switch from SQL Server to Oracle? No, unless you've got a ton of data. It takes forever. But the procedure to switch from Oracle or SQL Server to Oracle is fairly simple. it's just a time issue. How much time do you have for that data to get transferred from SQL Server to Oracle? Yeah, so Windows deployments are not supported for Service Manager and UCMDB. Linux-only containers are created and must be run on Linux. So in theory, when Microsoft comes out, right now they've got their Linux download packages you can run. Can you run Service Manager on those? Possibly, but you got no way to install the CDF, which does a lot of the work for you with the certificates. And I don't even honestly know everything it does, but it does a lot of work for you. So you'd have to deploy without the CDF, which probably is not supported by Micro Focus. So you'd have to run like a micro service of Linux on Hyper-V, something with that you could tell that into and install the CDF. So moving between deployments, I talked about this a little bit already, but basically, like I said, if you're on Windows, if you're on Windows Service Manager and want to move to Containerized, as long as you're on the same version that you want to go to on Containerized, you can just move. It's not a big upgrade or anything like that. You can just move. If you're on the same binaries, you could probably just go back and forth if you wanted. I wouldn't recommend running half Windows and half Containerized, but run one or the other, but it's pretty easy to move back and forth between them. So things such as INI files, log files, data, that's all held in non-containerized places for the most part. There's some exceptions where some database information is being held in containers, but it's database information that's being recreated when the container is rebuilt. So it's not important information. It's just basically runtime information. So you got the NFS shares you connect to Oracle database. Got the etcd files which are stored. Etcd is like a lightweight kind of sort of file-based database. Postgres, which is used by Service Portal, that's also a lightweight file-based database. So all those are stored in places that are static. They're not in containers. You can't destroy them and recreate them. So then you have to have your common, like if you have NFS information, you should have that backed up or fail over to somewhere. A lot of companies, their NFS shares are on SANs, so they're pretty bulletproof, but got to treat it just like your Oracle database information. It's important, and especially your Postgres data file, that needs to be backed up or something. Well, even the stuff in Postgres, if you lost it, you just recreate it when you restart Service Portal. So it's nice to have, but you don't really need it. So some of the things configured on your NFS shares are important. There's a lot of information about that Kubernetes uses, but most of your information is going to be stored in Oracle. That's where all your configuration information is stored, all your data, of course. So, and like I mentioned before, Service Portal only available in containers. Right now, there's no standard build for the product. I believe what comes with the 960 install is the old version of Service Portal. Not the new version of Service Portal. So they've only included the build for existing customers. But if you want the new version that they've got, then you're going to have to go containerized. So CDF upgrades. One of the issues, big issue with the older versions of CDF, is that every time you wanted to upgrade, move to the newer version, you'd have to uninstall the CDF and reinstall it, and then redeploy from there, which it wasn't a ton of work, but it's not as nice as just deploying your Docker container. So it would take hours, especially the uploading of the microservices into your CDF database. So that could take hours. So your downtime goes for an upgrade from literally minutes, just clicking a button and deploying, to hours, because you got to uninstall, reinstall. I mean, it's kind of a problem. So according to Micro Focus, this latest version, this February version, will be the first version that when they come out with the next version, you don't have to uninstall it and reinstall in order to upgrade. So this in my opinion is kind of the first like production ready version of the CDF where kind of the long-term vision is kind of being implemented, where your upgrades are going to be more one click, things like that. So So that completely simplifies your upgrades as far as the ITOM deployment. So future upgrades, so for most of the products, future upgrades are going to be pretty simple. You download the new Docker images, and then you upload them into your CDF, and then you go into your container, your CDF web management system, and there's like a little upgrade button that you click, and basically all it does is it destroys all of your existing Docker containers. It just takes them down. They call them destroy, but it just shuts them all down, and it just starts up the new ones. So it's really fast. I don't know how fast it is because we've always had to redo the CDF install, so we've never had this upgrade option. So the next release that comes out, we'll kind of be able to see how fast this upgrade takes. So of course, you still, these are binary upgrades. You're still going to want to do some testing in your lower environments just to make sure everything works the way you expect. Your integrations and all that stuff still work. But as far as deploying to production, I mean, just a button click and it's all handled. So very simple deployments to these binary upgrades. Some products still may need minor work for app upgrades. Service Manager, every few years, you're probably still going to want to do an application type upgrade. They're getting simpler and simpler because more things are process designer now, and they're just replacing less and less of the out of the box objects. So you're just having to merge less and less. Less and less and less. So SRC, if you're still in SRC and not Service Portal, there's some branding because SRC is kind of a file-based product as far as the branding and some of the how the screens show. But you still might have to merge that branding information and the screens. You still might have to merge that to get it to work. But for the most part, upgrades are going to be vastly simplified. And one thing that they're really going to push, of course, and with these containers, is that you upgrade everything at once. So you're on the same version of everything. Everything works together all at one time. So I don't know if there's going to be an option to upgrade, say, Service Manager, not UCMDB, or vice versa, because we just haven't had this upgrade capability before. So Micro Focus could probably answer that. My guess is maybe. I don't know. My guess is Micro Focus is going to say just to upgrade the whole thing. But you might have instances where you just don't want to touch your Service Manager, but really want to upgrade UCMDB to get some new functionality. Will that be possible? I just don't know. We'll just have to wait and see. My guess is probably, but we'll see. So can you use your existing Docker infrastructure? So I've been asked this because you kind of stuck with. Not stuck with, but you need to use the version of Docker that the CDF gives you, Docker and Kubernetes. So they've got certain versions of Docker, and companies that if you're standardized, you might have a standard Docker infrastructure already. You might be deploying applications, and you might think, yeah, I can just deploy these applications on my existing Docker infrastructure across my existing physical hardware. And you really can't. So you can't just deploy these things without the CDF, without this underlying container deployment foundation. So it is going to be for now managed separately. I've heard enough rumblings that possibly, maybe if Micro Focus figures it out, you'll be able to do a standard deployment across your Docker infrastructure, use your existing Docker versions and things like that. I just don't know. Micro Focus is pretty early on into this, as is everybody. This is all fairly new technology, but it's possible that might change in the future. So if you are a big Docker user and have lots of stuff deployed with Docker, that's a good thing to press Micro Focus on. That you want that functionality in the future to be able to deploy your Service Manager, UCMDB, Service Portal. It might share hardware resources in with your SAP, PeopleSoft, and other apps that if you've got those deployed in containers. So it becomes less about specific servers for applications versus total compute power in your infrastructure that you're deploying applications across. So some final thoughts. I've talked about some of these throughout the presentation, but each version of the ITOM containers has gotten easier. Definitely this last version, I think so far the only issue I've had is that I had to update my host file with my server names and IP addresses. And that's kind of a Straticom infrastructure issue because we don't have we're not really running Linux DNS. So I kind of forgot to do that when I first set it up. So that's one, the only issue really I've run into with this. Previous versions had lots of little issues. In fact, they've got a whole document on how to deal with those issues. Managing your CDF infrastructure, it's quite different than managing a standard deployment. So because you don't have applications running on top of servers anymore, how do you monitor that, right? Because they're not, you can't monitor through your OS layer anymore. It's different. These things are running in containers. So even your monitoring to see as, hey, a service manager running, your monitoring is going to be different in your Docker infrastructure. If you've already got lots of Docker and doing it, you know, your monitoring team is probably going to handle it. If you're not, you know, you're probably going to have to work with Micro Focus or someone like us to figure out how to monitor these Docker containers and see what's up, to see when something's not working, right? So in one sense, it's easier because you have one interface to manage your entire deployment. I mean, you go to the CDF interface, you can see your UCMDB containers and your chat containers and all your service manager containers. You can see them all from one interface. But there's definitely a learning curve, like where are the logs? How do I generate logs? How do I restart the containers? How do I add additional compute to the server farm? You know, how do I get the containers on that? And definitely, if you don't have this built into your infrastructure already, it just kind of takes some time to understand, even from the infrastructure side. So a lot of companies are used to having like, oh, these are my 5 service manager servers and my 4 UCMDB servers, and these are my 6 web tier servers, my server and my asset manager server. Here's my chat server. Now it's just I've got 6 servers and all my applications just run on them. So it takes a little time, even for the infrastructure people to get that concept and what is the benefit of that and how are we going to work with that. So, but I would say it's definitely, I mean, I can see most applications moving to this type of deployment. And I'll never forget, I talked to a client in like 2002, and he asked me, why do I have to deploy an operating system every time I want to deploy an application? Why can't I just deploy an application? You know, at that time I said, I don't know, that sounds great, but there's just nothing like that right now. So now there is. Now you don't have to deploy an operating system to deploy an application. You just deploy your application, you know. So it's really nice. So if you do have existing Docker expertise, you definitely have an advantage, because even though everything runs out of Micro Focus's CDF, it's still kind of standard Docker and Kubernetes. Like if you've got a Docker expert, he can just log into Linux boxes and look, and he can see, you know, a lot of information about these. If he knows all the kubelet commands and things, he can get a lot of information without going into the CDF. So in your monitoring teams are going to know how to monitor. So if you don't have an existing Docker infrastructure, you're probably at a little disadvantage, probably a little learning curve for some of those things. But I'll tell you, a lot of applications are going to be deployed this way. So this is maybe a good place to start. It's definitely in my mind the future. If not Docker, something else, but this deploying applications on top of operating systems in the future is going to be rare. It is going to be deploying applications on top of kind of this Hyper-V type layer over operating systems, kind of this layer. So you'll do less managing of operating systems and applications and how they're affected, and more monitoring of these containers and these microarchitectures. Oh, great. Laura put my contact information here, so you can just contact me directly if you have questions. So it's pretty new. I don't know, you know, some companies are doing this. I don't know if a lot of people have expertise in it in these companies. Definitely, I've done a lot of these deployments, a lot of the different versions. So I know quite a bit now. You know, it's been kind of a learning process for me along the way too. So it's going to be new for everyone. So if you do have questions, yeah, feel free to email me. I might be able to answer them for you. I might not be able to. Some of the things, you know, Micro Focus is just going to have to answer, especially the forward looking. So I'm presenting with them in March, some point in March. I'm one of the presenters. I think I only have 20 minutes. So I'm going to have to cut like like a lot, like 40 minutes out of this presentation to talk with them. So I'll have to decide what I'm going to talk about with them. But I think there's going to be 2 other speakers. So if you have more things, Micro Focus type questions, I'd be the one to attend. So if you don't know when that is, contact Steve or Laura, and they can send you that link. I think Laura's involved in setting that up. So I don't see any questions. Does anybody have any questions? Steve, did you see any questions come across?
No, I didn't. I was going to say, if anybody has a question, they could actually raise their hand and I could unmute them. I don't see any right now.
Yeah, and it looks like only about 20% of the people signed up showed. So I think a lot of people are going to want this downloaded. So I always try to do my presentations with information. My slides, I don't have a lot of pretty slides, but it's something that you can go back to and refer to, a lot of bullet points with information in it. So I always consider my presentations to be maybe a little more technical, a little more information based, a little more reference based, where you can go back and refer to it. And if you have a question, look through it and say, oh, that's what Docker is, or that's what Kubernetes is, or oh yeah, we can't use SQL Server. So I believe everybody got a link for this. Will everybody get a link for the slides, Steve? Probably, right?
Yeah. Yep. Yeah.
Okay.
Rodney does have a question. Service Manager is very customizable. How does that affect the use of containers?
It doesn't. There's nothing that you can customize in Service Manager that's based on the binaries, basically. So anything that you can do now in Windows or Linux deployments of Service Manager, you can do in the containerized version. There's no limitation there. It's exactly the same. In fact, as a developer, you wouldn't even be able to tell the difference between a containerized deployment of Service Manager versus, say, a Windows deployment of Service Manager as a developer. Everything would look exactly the same. You connect the same way. Everything would be exactly the same. So I can't think of a single thing that I've ever done on the binary side of Service Manager. Now, there's a few things I've done on the web tier of Service Manager, but it's mostly in older versions where some JavaScript files need to be replaced. Maybe I got a patch and replace some of those. So that would be a little different, but for the most part, in Service Manager, any tailoring you do, links, format controls, docket, the old doc engine stuff or any of the new process designer stuff work exactly the same. No difference.
Michael has a question here. Is there a summarized list of containerized applications available anywhere?
That's a good question. You know what? We should send out a link. Micro Focus has like a website for these applications. And so it's got the different pieces of it. So ITOM is one. They've got some other applications that are also containerized, and there's lots of information in there about what's containerized. So I think we can maybe, Steve, let's get together. I'll send you that link.
Okay.
It's the new Micro Focus like user board, and people can get in there and see. So, and I don't know if the question's for sure about just the applications, probably just the applications, but out of the ITOM suite right now, Asset Manager and Probe, you seem to be Probe, not containerized, but pretty much everything else is. So there's 101, I think, or 110 microservices when you download off the Docker site. Some of those are the new, the SMAX, I think 8 of them, but the rest are all for the existing. But yeah, there's other, they keep adding and adding. So even in this last version, they added some of the older software for like portfolio management and things like that. Those are being containerized too. So it's just kind of overwhelming with all the new apps that are being containerized. I'm just trying to keep up.
Looks like that's all we have right now. Anybody else have a question? Eric, can we make this slide deck available as well?
Yeah, I'd like, instead of just the webinar, we should have the slide deck available too, because it's a lot easier to go through.
Yeah. Okay. Yeah, that'd be good if you could just shoot it over to me when we're done.
Yep.
Just so I have it.
Sure.
Well, it looks like that might be it. Thanks, everyone. Have a good day. Thanks, Eric.
You're welcome. We'll
And
talk to you later.
everybody have a good weekend, and we'll talk to you soon.